this lesson we're going to talk about two other circle theorems. So the first circle theorem we're going to talk about is angles at the circumference. So what I mean by that is if I have two or more than that, so any angles at the circumference of a circle, if they're subtended by the same arc, they are equal. So what I mean by that is better sort of described looking at this circle. So subtended by the same arc, essentially that means they share an arc. So what I mean by that is note how on this diagram all of these angles at the circumference, they share that arc. They're coming from those same 2 points. So they're coming from those same 2 points, they share an arc. Those angles are all at the circumference of the circle, so they're there. And because of that fact, every angle is equal. Any angle I put along there is going to be equal. Another theorem we're going to talk about is that opposite angles in a cyclic quadrilateral are supplementary. So first of all, a cyclic quadrilateral, what that means, obviously it's a quadrilateral, but it has all vertices, so all points, touching the circle. So note in this diagram, the vertices of the quadrilateral are all touching the circle. Supplementary, what it means to be supplementary, it means they add to 180 degrees. So in this instance, these two angles, so gamma plus theta, that's going to be equal to 180 degrees. And likewise, alpha plus beta, that's going to be equal to 180 degrees. So using this knowledge, we'll just now do some examples. So example 1, we're trying to find x in this circle. Now this is a cyclic quadrilateral, so x and 109, they're going to add to 180. So solving this, we get that x is equal to 71 degrees. If you didn't know how to do that, you could have used the fact that quadrilateral sums, angle sums are 360, and you could have solved it that way. The second example is we're asked to find x. Now, it's a bit hard to look from this angle, but if you were to flip the circle, you could see that this angle there and this angle here, they actually share an arc, or they are subtended by the same arc. Because of that fact, this angle here is actually x as well. And we know triangles add to 180, so we could say that x plus 96 plus 48, that's equal to 180. And we could solve from there. And we'd say that x, that's equal to 36 degrees. So we'll work through example 3 now. So 3a, we're asked to find the values of the following pronumeral. So we need to find a and b in this first part. So first of all, a and 64, they are opposite angles in a cyclic quadrilateral because it's four-sided shape. So a plus 64, that's equal to 180. Solving backwards, we get that a is equal to 116 degrees. So if we now have a equaling to 116 degrees, so write that over, we can view this as a triangle. And we know triangles add to 180. So we could say that b plus 116 plus 26, that is equal to 180. Solving backwards from here, we would just get that b, that's equal to 38 degrees. And that would be my answer. Part B is a little bit more challenging. So, if I were just to view this triangle here, note how they're coming from the same point in the circle, perhaps the center, we can't guarantee. But those little lines here mean they're the same length. Because they're the same length, it must be an isosceles triangle, so this must also be A. So we would get that 2A plus 80, that's equal to 180 degrees because it's a triangle. So the three angles all add to 180. Solving backwards, we get 2A is 100, so A is equal to 50 degrees. Trying to find B now, we know that opposite angles in a cyclic quadrilateral sum to 180. So this angle here is actually opposite this angle here. So we get that A plus 36 plus B, that is 180. We know what A is, so it becomes 50 plus 36 plus B equals 180, and we just solve from there. Get B plus 86 equals 180, so B must be equal to 94 degrees, and that is my answer.